In the TinkerCAD dashboard, two main part of TinkerCAD is 3D design and circuits. Okay, so in circuit you can create an electronic circuit and simulate it. Okay, you can also program it using Arduino programming language. So if you already have a TinkerCAD account and you already have been played with it, you will have your circuit project here. So now let's create a new project. So you will be greeted with this kind of interface. Okay, this blank workspace here. So for the first thing, just change the name of your project. Just click at the name and press enter. So it will change the name. Okay, in the right hand side you will see the component category. So for now, by default it is displaying the basic components in here. So we have some LED, resistor, push button, battery, Arduino, motors, DC motors and servo motors, and multimeter. So let's change the category to all. So we will expand the variety of choice on components that you can choose. Okay, we have capacitor, diode, inductor, and photodiode, more sensors, keypad, more LEDs, more motors, and IR remote control, battery, breadboard, and microcontrollers. Okay, so we will mainly use Arduino. So we also have multimeter and oscilloscope and ICs, and we also have a motor driver and more ICs. Okay, so let's get back to the basic. Okay, so if you want to put a component in your workspace, you just click on your component, click once, and the component will stick to your cursor. Okay, you don't need to hold the left click and drag. Okay, just click once, so the component will stick to your cursor. So just place it anywhere, click once. Okay, then to pan your workspace, just hold left click anywhere, so you can move your workplace. If you want to move your component, you just hold left click on any component, so you can move it. Okay, then you can name your component anything. Okay, why you can name the component? This is because even for Arduino, the microcontroller, you can use many Arduino at the same time. Okay, you can activate many Arduino at the same time. When you start the simulation, all Arduino available in this project will be running at the same time. If you're using more than one Arduino, you cannot run only one Arduino at a time. Okay, once you start the simulation, it will run all the Arduino. Okay, next is, let's see how is the coding. Press the code here. Okay, you will be greeted with this interface. Okay, this interface is very similar with Scratch programming language, which is a blocky drag and drop programming language. Okay, it is easy to understand and mainly used in primary school. Okay, so it is easy to understand, but of course we don't like easy things, right? We always love complicated things. So click at the block, so choose text mode, press continue. Okay, now you will be greeted with this kind of interface. This is a very similar with Arduino IDE software. Okay, there are also block and text mode, which is the same as block mode. Okay, you can coding with Scratch language, and then you can see what happen if you do a thing in the Scratch language, and then it will update the programming script here in text mode. Okay, but you can only edit in block mode. You cannot edit in this text mode. Okay, you cannot type anything here. So let's get back to the text mode. Okay, this is the basic coding of LED blinking of Arduino using the built-in LED on Arduino. So for now we just delete it. Okay, the first thing that you need to know when you open the Arduino IDE for the first time is the layout of the Arduino programming. So you will be greeted with these two main functions, namely setup, void setup, and void loop. Okay, in every Arduino programs you need to include these two functions. Even if the function is empty and you didn't use it at all, but you must include both of it in any program. So in void setup, anything that we put in here will be run once, and then it will go to the void loop, and then anything that we put in void loop will be run forever. Okay, it will run forever if there is no condition to terminate the loop. Okay, so we have been talking about declaration. So only declaration of variable and function that is allowed to be outside of any function. Okay, so supposedly we declare variables and functions at the beginning of the program. Okay, generally we know that a function may look like this. Okay, so this is basically a function, any function that is built in Arduino or you create by yourself. So this is a basic form of a function. So this is inside the function. Okay, so anything except declaration of variable and function must be inside of this function. Okay, for example, for loop or if or switch. Okay, you cannot put the switch or if or the for loop outside of the function. Okay, it will result an error. Okay, so usually there's some situation that we need to initialize a function. For example, for serial monitor we need to use serial begin. Okay, and then to initialize the pin that we use, to declare the pin either is input or output, we use pin mode. So both of that thing we put in void setup. Next is serial monitor. Okay, which we have been learning a lot about serial monitor. In Arduino IDE, the position of button to open the serial monitor is on the upper right corner around here, but in TinkerCAD the serial monitor is at the bottom here. Okay, we press the serial monitor, so this is the serial monitor. You can input anything here and you can output anything here, and this is for clearing the output. Okay, so now let's try some example for serial monitor programming. Okay, now let's just start the simulation. Okay, as you can see, when we start the simulation, the USB will be plugged in. Okay, and then there are some lightning icon here will appear, and next the on LED here will turn into green. If we stop the simulation, the on LED will turn off and the USB will be plugged out. Okay, so let's see what happened with our programming. We press serial monitor, so you can see here it is playing 2 times because we run the simulation 2 times. So we'll just clear again and then we start again. Okay, it's displaying this sentence. Okay, So what happen if we put this into this? Okay, now it will repeat forever. Okay, as you can see here, it is repeating forever because it is in void loop. Okay, so another example, what if we just write serial print? Okay, then we start. Okay, so when there's no ln here, it will continue to print without entering a new line. Okay, next let's try some hands-on on the electronic part. Okay, you don't need to worry about the coding, as you can refer to the TinkerCAD module. All of the example of the connection and the coding are included in there, so you just copy everything in there. There's some explanation, and if you don't understand, you can ask your mentor. Okay, so next let's just pick a breadboard. Okay, and put it aside. Okay, so for those who doesn't know what is breadboard, so breadboard is a prototyping board, which is all the hole is connected in specific ways. Okay, for example, as you can see, this 5 row, okay, and this 5 row all connected vertically. Okay, so if I put the cursor here, you can see the green circle is highlighting all the hole that is connected to it. So this 5 is connected together, and this 5 is connected together. Okay, this and this is not connected. Okay, now for this part, it is connected in horizontal way. Okay, if as you can see the green circle here. So if you want to put any component, you need to make sure that the connection is right. Okay, let's have some LEDs here. You can rotate your component by pressing R. Okay, so let's put this LED on the breadboard. Okay, so LED, you can change the color to whatever color you want. Okay, and then if you put your cursor to any terminal or pins, if that pin is not labeled, it will prompt to you what the pin is. Okay, for example, if the Arduino didn't provide this label and you didn't know what pin is this, you just put the cursor there, and then the label will be prompt out to you. Same to the LED, if you put a cursor here on the one of the leg, it states that this is anode and this is cathode. Okay, now for the wires, let's connect the wires. Once you press, you can connect the wire any way you want. Okay, to lock the wires or to make a turn, you just left click once. Okay, okay, you can also adjust your wire by holding any point and dragging it anywhere. So as you can see, the blue line indicating that my wires is in 90°. Every wire you put, you can also change the color. Okay, for 5V we use red, and then for ground we use black. Okay, so for LED, first we need a resistor. The same thing, you can also change something in the resistor, which is the resistance. We commonly use 330 ohm resistor for LED. Okay, so next we just connect the wire, and then ground. Okay, so let's see how I'm connecting this. Okay, from pin 2, so I will connect to this line, and then this line connect to the resistor, and the resistor bring it to this line, and in this line it's connected to the LED anode, and then the LED cathode is here connected to the ground, so the ground will be here, which is carried by this wire to the Arduino ground. Okay, so let's look at the coding. Okay, first thing first, we need to do the declaration of the pins. So we are using pin D2 as the pin for LED, so we need to use pin mode 2, and we use it as output, which is we use for LED, and then we just write digital write pin 2 high. Okay, make sure the W is capital W, and then you write it low, so we'll open and close. Next, we need to add some delay, so the delay is in millisecond. 1000 millisecond means 1 second. So let's see how it goes. Start the simulation. Okay, as you can see, the LED on, off, on, off. For 1 second it's on, and then it off for 1 second. Okay, so this is all the basic that you need to know how to use TinkerCAD as a simulation program. TinkerCAD collaborate with Arduino language, so you can program any board that compatible with Arduino language. Okay, for now, the microcontrollers that included in TinkerCAD only 3, which is Arduino Uno, Tiny, and Microbit. Okay, let's have a look. Stop, code, and okay, all. Okay, so as you can see here, these 3 microcontroller available for simulation in TinkerCAD. Okay, and this 3 is compatible with Arduino language, means you can program these 2 with Arduino IDE. Okay, and then another thing that you need to make sure when you do project, either in simulation or in real life, okay, make sure there is no shortage, which is 5V and ground not connected directly, or it will damage your components. Okay, in the TinkerCAD simulation, if you do electronic errors, which is short or wrong pins connection, there's no error will be from here. But if you do programming errors like no semicolon, okay, or wrong words, it will display errors here. Okay, during this hands-on session, you will learn a lot of things about how you can use Arduino IDE to program others electronic component. So other thing that you may learn in the hands-on session, okay, referring to the programming modules and the TinkerCAD module that I've give. So you will learn how to use serial monitor to input a value from ourselves, a user. Okay, so we use variable, char variable, which is character variable, which only hold one single letter, and then in void loop, okay, we use this function serial available. So we want to check if there's any input in serial monitor, then it will run anything inside it. If there's no input in here, means we didn't type and press enter here, so it will do nothing. Okay, so once we type here and press enter, it will read whatever we write and then put it inside the variable name letter, and then we print it again, serial print letter. So let's test it. Okay, serial monitor, so it displaying hello Jazari from here, from the void setup, and then we just put letter B. Okay, so now it displaying my favorite letter is B, so it displaying this line, and then it displaying the variable letter. Okay, in serial monitor, the only data type that we can input as a user inside the serial monitor is only char, only character. So if we put integer or a sentence or a word, it will result a garbage value in the serial monitor. Okay, next thing you will learn is how to read analog value. This is a potentiometer, so this is its knob, so we can rotate it. So let's see at the code. Okay, and we press start. Open the serial monitor, and as you can see, the value it is displaying 1013. If we rotate, it will update the value. Okay, as this is only simulation online, so the value may be inaccurate, because it's like we turn the knob, and then once we release, it will update the value. If we still holding the knob, sometimes it's not updating the value. The value of potentiometer usually from 0 to 1024. Okay, so this is displaying 1013. So we use the function analog read here to read analog value from pin A4, which is the pin that we connect the potentiometer. Next, you will learn how to control or give analog value to analog component. LED can also be used as analog component. Okay, you can control the brightness of the LED from value 0 to 255. Okay, so here we are going to use for loop. Okay, and we are going to start the value of the LED brightness from 0 until 255, increasing by 5 each time. Okay, so let's look how it goes. Okay, as you can see, the LED now light up, and then it's off, and then it will light up again. So again, as this is a online simulation, it may not look realistic, but for the on animation, it looks like digital. Okay, from previous example, so you can compare by yourself if you do the coding. But the off animation, it slowly turn off. Okay, from bright it slowly turn off. So that's how we write analog value. Okay, so this is we turn on from 0 to 255, slowly increasing by 5, and then when the LED brightness is at max value, which is 255, we decrease it by 5 each time, so it will decrease slowly until it turn off. Okay, the next thing is we will use push button to read digital value. Okay, last time we only write digital value to LED, and we write analog value to LED, and we read analog value from potentiometer. So now we are going to read digital value from push button. Okay, this is the example code that you can refer in the TinkerCAD programming module. We're using if statement to measure the state of button. Okay, and we use digital read, okay, to read the button, while the button here is the variable button name button that holds value 4, which is the pin number that the button is connected. We read the value from the pin, digital read, and input it into a new variable named state, and then we are comparing the variable state, the value of the variable state. If we press the button, the variable state will be 1, okay, because the digital read will read the button and get the value 1. So what we do here, we set LED 1, which is the green one, to on, and then we set the LED 2, which is red one, to off, and then else mean if the state is not 1. So in this situation, if not 1, which means 0. If we not press it, that's mean the switch is unpressed. So when the switch is unpressed, we do LED 1 off and then LED 2 on. Okay, let's look at how it goes. Okay, as you can see here, the LED 2, which is red, the red LED already turned on because we didn't press the button. Okay, the button is in unpressed condition. So if I press the button, okay, the LED green will light up and the red LED will turn off. If I release the button, okay, the green LED will turn off while the red LED will turn on. So this is the most simple example how you use the if statement to compare a variable. Next, we use LEDs again, but this time we want to use switch statement, and we are going to use input using serial monitor. Okay, don't worry, the coding is in the TinkerCAD programming module. You can copy from it. If you have any question or any errors in your writing, you can ask your mentor. Okay, so what we do here, we name the variable LED 1, 2, 3 from pin 2, 3, 4, and then we declare it as output, and then we begin the serial monitor. Okay, and then we print some stuff. Print switch, input a small letter. Okay, so again, this serial available. If there are input here, if we input something and press enter, and then it will read the value, else it will not read anything here. Okay, once we input the letter, it will display again what is our letter that we just input, and then the switch will take the variable input, which is we take the input from user using serial read. Okay, then the variable input will be compared inside this switch block. We have 3 cases here, which is small a, small b, and small c, and another one is default case. When the letter is neither small a, small b, or small c, then the default case will be executed. So in case of small a, we light up LED 1, which is green, so green here, and then if small b, yellow here, and the other 2 is off. If small c, red will on and the other 2 is off. So other than this, at the D, E, F, or if you put capital A, capital B, capital C, it's not the same as small letter, so the default case will be execute. So let's see how it goes. Okay, so let's put small a. Okay, green LED on. So small c. Okay, LED red on, green off, and then small b. So yellow on, red off, green off. Okay, and what if we put Z, for example? So all off. Even we put capital A, okay, all off, because no capital A in this case. So this is a basic example on how you want to use switch. Okay, so now I will show you how you want to use function. Okay, you'll learn also function in the TinkerCAD programming module. So this is very simple. You just declare first here void function or any name that you want to use, and then at the bottom here declare again void function. Now you need to specify what the function does. Okay, so what this function does is it will do all these things. Okay, and we put it here. So inside void loop it will look like more simpler. Okay, we can also include this reading inside our function. Okay, so in void loop now we will look more tidier. So how we gonna use our function? We call our function. So our function name is function, so we just write like this. Okay, it will run all the things that we specify in our function. So let's look, is it the same? Okay, let's test. Clear first. A. Okay, green. B. Yellow. C. Red. So it works the same as previous one. So that means that our function is correct. As I've been sharing with you, that function act like a flashcard, which make your coding look tidier in the main part, which is our main part now is the loop. If you just use functions inside the main part, okay, so it will be easier for other people to track what are you doing. Okay, instead of you just put all of this stuff inside the main function, and then when you share it with other people, it will be a little bit hard to track what happened here, what happened when. Okay, so function help us to simplify the code and to help other people to understand our code. Okay, lastly you will learn how to use a motor driver. Okay, so when we use a DC motor, it only have 2 pins, which is control the direction. Okay, and if we only use these 2 pins directly to Arduino, we cannot control the speed using coding. Okay, and the speed will 100% depends on the power of the power source. Okay, that's the first issue. And then the second issue is, if you use a lot of motor and then you are going to share the power source by the Arduino, and it will be hard for Arduino to work, and sometimes it will force the Arduino to restart the board. So if you're doing any wireless project like Bluetooth or PS2 or any other wireless, so it will be disconnected and then reconnected, and this will be a problem to you. So we use a motor driver, which is we can integrate with Arduino to control the speed and the direction. At the same time, we can separate the power source of the motor. So now the Arduino is using the power source from USB, which is 5 volt, and then this motor is using the power from this battery, which is 9 volt. So the pin, the connection, you can refer to the module. So let's see how to write the code about motor driver. In 3, okay, we put into pin 4 and pin 3, and then enable 3 and 4. Okay, enable we put in pin 5. So enable is a PWM pin. Okay, you need to connect with PWM pin in Arduino. So the output pin you connect to the motor. As we know that when we use PWM pin, it is a digital pin, but you can use it to write analog value. Okay, as you can see here, we are using a digital pin, but we are writing using analog write. Okay, so for the input 3 and 4, usually controlling the direction of the motor. Okay, usually when we first solder or connect our motor, we didn't know what direction is front, what direction is front and what direction is back. Okay, so we test it which direction, and if the direction is not satisfying, so we change the pin here, or we change the connection here, so that the direction will be as our intent. Okay, so here the example, I assume my motor will run in one direction. So if you want the motor to run in one direction, you need to set one input to 1, one input to 0. You can also write this as high and low. Okay, and then you need to specify the power. Okay, for the single motor movement, you need to write these 3 lines. Okay, so for 2 motor movement, you need to write 6 lines of this. Okay, so let's look how it looks like. Okay, as you can see, it's rotating 190 RPM. Okay, so which is almost the same as the power that we specify here. Okay, and you can also see this shaft is rotating. That means your example is working perfectly. Okay, so let's say if this number is negative 190, that means your pin is not in the correct orientation. It's not dangerous, but it's just will rotate to opposite direction. Okay, so as you can see, because again this is a online simulation, so the rotation is a little bit slow, but actually in a physical example, 200 is pretty fast. Okay, and the maximum value is 255. Okay, so also as you can see here, this is second. Okay, time in second, 5 seconds, but it move very slow because of my laptop. Okay, it a little bit slow, not because the time is slow, but because of my performance of my laptop. Okay, so if you have a good hardware to simulate this, so you may see this in real time, and this shaft should be rotating fast. Okay, so that's all that you will learn in the hands-on. I hope that you understand, and you will be interested to join JoRW Innovation Club. Okay, if you have any question or any error during your hands-on, you can ask your mentor, or if your mentor cannot ask your wonderful question, and then you may ask me directly. I'll be going to group by group, and you can ask me directly. Okay, so see you at JoRW online recruitment game. Good luck.